Welcome to qnawire.
Okay, our question says to let v1 vector 1 equal minus 6.0 I hat plus 8.0 j hat, and v2 vector v2 equal 4.5 I hat minus 5.0 j hat. And it says determine the magnitude and direction of A, v1, B, v2, C, v1 plus v2, and D, v2 minus v1. Okay, so we're going to go ahead and do that. I have written out here what we were given, which was v1 is equal to minus 6.0 I hat plus 8.0 j hat. v2 is 4.5 I hat minus 5.0 j hat. And then I also over here, I will go ahead and circle it, drew the coordinate system, right, of the direction. Ooh, that's not a very good circle. But you saw where I was trying to point out here, right here, where that arrow is. That's the coordinate system for I and j hat, just so you can kind of get a visual representation. And so first we want to get the magnitude so I wrote what we want to determine as far as magnitude and direction goes in red for the different scenarios of A through D. So we always have a reference of what we were trying to determine. So the first thing we want to do, which I'm going to solve here in black, is find the magnitude of V1. Okay, and the magnitude of V1 is just going to be the square root of the square of both sides. So it's going to be minus 6.0 minus 6.0 squared plus, and then the other one is 8 squared, which is in the j hat direction. Okay, since they're not in the same direction, you can't add them together. You can only add together things that are in the same direction. Okay, and if you carry this out, you get 10 10.0. Box that in. Okay, and then the next thing we want to do is determine the direction, right? Not just the magnitude. So we're going to make use of our trigonometric identity, tangent theta for v1 is equal to the opposite over the adjacent. And the opposite here in this case is going to be what is in the j hat direction, right? So it's going to be 8.0 divided by what we see in the I hat direction, which is 6.0. But this is negative 6.0, okay? Well, we're going to go ahead and solve this for theta. And that's equal to the inverse tangent, which is represented as tangent minus 1, written as tangent minus 1, the inverse tangent of what we just had, which was 8.0 divided by minus 6.0, right? And if you do that operation, this comes out to be 127 degrees. Okay, go ahead and box that in. So there's magnitude and directionality for A. Now for B, we want to do this for V2. So for V2, first, let's do the magnitude. Well, that's going to be equal to the square root of the square of the two sides that make up V2, which is going to be 4.5 degrees, or I'm sorry, not 4.5 degrees, just 4.5 squared, and then plus minus 5.0 squared, but a negative number squared is just going to be positive, so we can just go ahead and write that as positive. And this equals 6.7. Now, we also want to find theta for this scenario, and it's going to be the exact same formula where theta is equal to the inverse tangent of the opposite over the adjacent, but this time the opposite is minus 5, right? Because j is minus 5. Not 50, 5.0. So make sure we got a little decimal place in there. There we go. And then divided by 4.5. This comes out to be, if you do this calculation, 312 degrees. Okay. All right, now it's going to get a little bit more tricky because we have to add V1 to V2 and then find the magnitude and the direction. So first thing we're going to do is go ahead and calculate what V1 plus V2 is. Well, V1 plus V2 is equal to, you can only add the like terms. So things in the I hat direction or things in the J hat direction. So you have minus 6.0 plus 4.5 right? And this is all in the I hat direction. Okay. And then you are going to add to that what's going on in the J hat direction, which is 8.0 minus 5.0. And this is all, close these parentheses. Oh, those aren't very good parentheses. In the J hat direction. Okay. And if you go ahead and carry this out, you'll find that this comes out to be 4.5 or I'm sorry, 4.5 plus 6.0 or plus minus 6.0 is minus 1.5 I hat. Okay. And then for the J hat, 8.0 minus 5 is plus 3.0 J hat. Okay. So now we can determine the magnitude of V1 plus V2. And same as before, it's the square of both sides that make up V1 plus V2. So it's the square of 1.5. Square of a negative number is a positive number, so we can just write it as positive version. 1.5 squared plus the other one, which is 3.0 squared. And this comes out to be 3.4. Okay, box that in. And we also want to determine the direction here. So same as before, theta is equal to the inverse of the tangent of the opposite over the adjacent. In this case, opposite is 3, and the adjacent is minus 1.5. And carry that out, and you'll find this equals 117 degrees. Okay, and lastly, we want to find V2 minus V1. So let's go ahead and draw some lines here. So we can separate out our solution for D from the solutions for the rest of them. So let's just go ahead and write it next to this. So V2 minus V1, well, we have 4.5 minus V1. Well, what's going on in the I hat direction in V1? It's 6.0, so it says minus, right? And this is all in the I hat direction. And then we are going to add to that what's going on in the J hat direction. And I don't want to bump into the graph here, so I'm going to erase some of this graph because we've already discussed this, what that is. So that way I have room to write what's going on in the J hat direction. Okay, so that is, well, it's not a plus sign, it's minus because we're, excuse me. It's a minus here because we're subtracting V2 from V1. Oh, and actually, yeah, we're subtracting V2 from V1, so this is a minus sign. That's correct. Okay. All right, so now subtracting, oh no, it is a plus sign. Yeah, the minus sign comes in here, 4.5 minus 6.0. Apologize about that. Okay, so this is a plus sign here. So now we're going to add to what's going on in the J hat direction. So minus 5.0 from V2. Subtracted what's going on in V1. Subtract 8. And this is all in the J hat direction. Okay. Make those parentheses as large as each other. Okay. So if we go ahead and carry that out, we will find that this equals minus 4.5 minus 6.0 is the same as 4.5 plus 6.0. So that is 10.0. And that's in the I hat direction. And then plus what's going on in the J hat direction is minus 5.0 minus 8.0. That is minus 13 J hat. Okay, so now we want to determine the magnitude of V2 minus V1. Oh, magnitude represented again by these bars. Okay, so that's going to be same formula as before, the square root of the square of both sides added together. So we have 10.0 squared, and then plus minus 13 squared, but a negative number squared is just a positive number. So we can write plus 13 squared. Okay, and if you carry out this operation, 4.5 minus 6.0 is not 10.5, or I'm sorry, is not 10.0. It's 10.5. Let's correct that little mistake. This is 10.5. And then so same thing in here. That's 10.5. Apologize about that. So 10.5 squared plus negative 13 squared, all square rooted, is 16.7. Okay. So there's our magnitude. Now we, again, same as before, we want to figure out directionality. Same equation using our trigonometric identities. Inverse tangent times the opposite over the adjacent. And then the inverse tangent of the opposite over the adjacent. And in this case, opposite was 13. And the adjacent, well, that was a minus 13. And the adjacent was 10.5. Okay. And this comes out to be 309 degrees. All right. Box it in as our direction for part D.